to sketch this graph. That's what the question says. According to this information, f of 2 equals f of 4 equals 0. I'm going to sketch it two ways. Here's f of 2, f of 4, and I'm going to do the same thing over here. And so f of 2 is 0, and f of 4 is 0, so it touches 0. F prime of x is less than 0 for x is less than 3, so it's decreasing. The first derivative of f of 3 does not exist. So one way for it to not exist is if there's an asymptote there. And then f prime of x is greater than 0. So it's increasing when x is greater than 3. It's decreasing when x is less than 3. And the second derivative is less than 0, meaning it's concave down in both places. So it could look like that. That should be approaching but never touching. I have a hard time drawing that, approaching but never touching. So concave down in both places. Alternatively, here's x is -3. It's 0 at 2 and 0 at 4. So I put that in at both spots. And again, it's got to be concave down on both sides of 3. So it could come like this, and then it could have a point at x equal 3. That's where the derivative doesn't exist, and it could look like that. So either one of those is possible. F of 2 equals f of 4 is 0. Both of those have it. The derivative at x is less than 3 is less than 0, meaning it's decreasing. So you can see the graph is decreasing. Less than 3, both cases. It's getting smaller. The derivative of f of 3 does not exist, so there could be an asymptote there, or there could be a point where the derivative doesn't exist. The derivative is greater than 0 when x is greater than 3, meaning it's increasing. In both cases, it's increasing. So there you have it. Those are two such graphs.